It is Wednesday the 27th of January and we're going to look at the final exercise on pulleys, and that is exercise 21G. So I'm going to look at question 1 and then I'll upload this as a PDF and then you can work through the rest of the exercise. Exercise 21G starting at question 2. So back to question 1. Two bodies of mass 2 kilograms and 5 kilograms are connected by a light inextensible string which passes over a smooth fixed pulley. Everything so far, there's nothing new. Body A lies on a table, but it is a rough table. So that is the new part. That's the new thing we'll have to consider. There's a rough table, so whenever you see rough, you have to think friction. So body A lies on a rough horizontal table and body B hangs vertically. So B is just the same as it was in the previous exercises. We are told the frictional force acting on A. So it's a rough table and it tells us what the frictional force is. So same two questions to start off with, acceleration and tension. So let's look at our diagram, and all of our diagrams are going to look exactly the same except for the values. So let's take our B. Object B is 5 kilograms, therefore 5G acting down 50 newtons and the tension acting up. So you can do 50 minus T equals MA. The resultant force is equal to MA. Let's look at object A. Previously, in the previous question, the only horizontal force acting on this was the tension. So the tension was equal to mass times acceleration. But now what we have is we have a rough table, so we have friction pulling against it. So we have a force acting against the tension. So the resultant force, remember for F equals MA, we're always talking about the resultant force. So the resultant force in this case is going to be T subtract 16 newtons. So that is T subtract the friction. And that's going to be equal to mass times acceleration. So this bit wasn't in the previous exercise. So it was just T equals MA. But we have to do that subtraction and then let that equal to MA. And once you get that part done, it's just exactly the same as the previous exercise. You have two equations. This is the equation for object A. T minus 16 equals 2A. This is the equation for object B. 50 minus T is equal to 5A. Adding them together gets rid of the T's. So just like the last exercise, you're left with the value of A. Part B, exactly the same as the last exercise. Once you have A and you're asked for T, you just substitute it in to either equation that you've come up with here. And in this case, I've substituted it into the first equation. So T minus 16 is equal to 2A, but now we know what A is, so just times it by 2. So nothing really new there, apart from the fact that we have to subtract for object A to get the resultant force. Now, let's go up to the questions again. B hits the ground after 0.48 seconds, and we're asked to calculate the velocity with which B strikes the ground. So, after just clearing away all the stray marks there, let's look at how to calculate the velocity of B when it strikes the ground. So, before I show you the answers, let's just see what information we have. So, B hits the ground after 0.48 seconds, but remember, they start from rest. So what we have here is we have U equals 0. We have the T equals 0.48. We are looking for V. Now what else do we have? We have worked out A. So we're going to do that with all that information. So for body B, here we go. Starts at rest. Accelerates at 4.86 meters per second squared from part A. The time it takes is 0.48 from the equation. We're looking V. The equation that connects V, U, A and T is V equals U plus AT. So sub it all in and then you'll get your value of V. Let's go back up and look at part D and ask what it asks us. After body B strikes the ground, body A continues to move. assuming A does not reach the pulley, find the time it takes A to stop. So just looking at our diagram, this object here is going to fall down and it's going to hit the ground. And while that's happening, this object will be pulled to the right and it's going to continue moving until it stops. Now it's not going to hit the pulley, it'll continue moving even after object B hits the ground. Now we are asked for the time it takes A to stop. So just looking at object A and thinking about object A, so we start to think about suvat, and we're talking about the time it takes for it to stop. So time is what we're looking to find out. Whenever it stops, the final velocity is 0. Now we do know the initial velocity, because the initial velocity of this part of object A's movement is the final velocity of object B. So that was 2.33. Remember, we're looking for the time it takes to stop, but we don't have enough information there. SUV, AT, we only have 2 bits of information, but there is one other thing we can calculate, and that is the acceleration. Now, how do we calculate the acceleration of object A when it's coming to rest? First thing I want you to think about is, if something is coming to rest, the acceleration is going to be negative. So let's go down to my working out. So we're now modelling object A. So this initial velocity comes from here. It's the final velocity of object B. This final velocity is 0 because it's whenever it comes to a rest. Now what we're going to do is calculate the acceleration using F equals ma. Because the only force for this part of the object A's movement, the only force acting on it is the force slowing it down. The only force acting on it is the friction acting against the direction of motion. So what I've written here is the only force is friction. It acts opposite to the motion. Therefore, the friction is a negative force. So the force is the friction, and that is equal to mass times acceleration. The force is negative, so that is equal to the mass times whatever the acceleration is. So divide 3 by 2, your acceleration is minus 8 meters per second squared. I've mentioned earlier the reason why it's minus. If you have an acceleration that's negative, that means it's slowing down. So you need to use F equals ma, and we've done this in previous exercises for objects that are coming to a rest. You need to use F equals ma to get A. It's going to be negative, and then plug it into V equals U plus AT to work out T. Part E, we're asked for the distance that A travels before stopping, so we're just using the same information. Using the same suvat for object A, but now we're looking at S. So we have U, V, A, and T. We're looking for S. So what I've used is V squared equals U squared plus 2AS, and then rearrange to find S. So all of these questions are very similar. That was question 1 that I've just done. Question 2, look at, there's 5 parts: acceleration, tension, velocity, time, distance. So here we go: acceleration, tension, velocity, time, distance. Question 3, acceleration, tension, velocity, time, distance, and so on. So all the questions are very, very similar. So work your way through those, and I will put up solutions to them later in the week.